All right, so today what we're going to do is we're going to multiply some more polynomials. But before we get into our lesson for today on multiplying polynomials, we're just going to do a quick review on adding and subtracting polynomials, and then a quick review on how we multiplied easier polynomials. So the first thing we learned was adding and subtracting polynomials. So this right here is a polynomial. This is called a binomial because it's two terms. This is one term, subtract. This is a second term. Okay, it's a two-term polynomial. It's called a binomial. If we want to add and subtract polynomials, they have to have the same letters and the same exponents. So when you look at example 1, those two things, the x and the y, cannot actually be combined, and that would be your simplified polynomial. But if you look at number 2, these are called like terms because it's the same letter and the same exponent. So if we wanted to add these two things together, we just have to add their coefficients. 2 plus 5 is 7. That combines to become 7x. It's called collecting like terms, and it was key for us in multiplying. If we look over here, we have a couple more examples. So for number 3, if I want to collect like terms, x squares would go with x squares. So 2 plus 4 would be 6x squared. And then x's would go with x's. This is an invisible 1x. So 3 minus 1 would be positive 2x. And that would be your answer. If we look at number 4, same idea. X squared y can only go with other x squared y's. So 2 plus 3 would be 5x squared y's. And then xy's can only go with xy's. It's an invisible 1 right there. So it'd be positive 6xy. Sometimes people think those are like terms because they're both xy, but they're not because the exponent is not the same. So those are not like terms. They cannot be combined. That would be our answer. Cool. Multiplying. We learned how to multiply some polynomials. We start off with monomials like this. We already know how to do these from the previous unit. The coefficients multiply together, so 2 times 6 would be 12. And x and y actually can't combine, so you just write it xy. They can't combine because they're not the same letter. If you look down here, we go numbers with numbers, so 2 times 5 is 10. And then the x and the x squared actually can combine. We would add their exponents, so it would be 1 plus 2 to become x to the power of 3. Here we learned that last unit too. All right. Then we had situations like this, where we had a monomial. This is a monomial. It's one term multiplied by a binomial. One term plus the second term, that's a binomial. To multiply these together, we did something called distribution. So we would take the 2x and we would distribute it to the 6. So 2 times 6 is 12, and then x. And then we also distribute it to the y. So 2 times an invisible 1 is 2. X times y is xy. That's called distribution. It's my main way of multiplying. Fantastic. Number 4. We got this guy right here. This is a binomial times a binomial, right? So 1 plus a second term, that's a binomial. 1 term plus a second term, that's a binomial as well. We had 2 strategies for this. Strategy 1 was distribution, which means you take that 2, you distribute it to the 6 to become 12, and you distribute it to the y to become plus 2y. You then also take the positive x and you distribute it to the 6 to become plus 6x. And then you distribute it to the y to become plus xy. That was one strategy. The second strategy we had was called an area diagram. So an area diagram, you take your first binomial and you write it across the top like this, and you make a little chart. Then you take your second binomial and you write it down the side. And then you filled in the middle of the chart. So you'd go 2 times 6 is 12. 6 times x is 6x. 2 times y is 2y. X times y is xy. And those green numbers that I just wrote are your answer. 12 plus 6x plus 2y plus xy. And you'll notice that both these answers are the same. Right? It's just two different strategies. First strategy was distribution. Second strategy is called an area diagram. Most people pick one that they really like and then they kind of stick with it. I usually do distribution. Cool. Today, what we're going to do is we're basically just going to practice more multiplying. It's going to be the same stuff, just bigger questions. So the last lesson, the biggest we ever did was a binomial and a binomial. Today, we're going to do all the way up to, I think, a trinomial times a trinomial. Oh, no, just bi times tri. So if we look, I have a monomial times, this is a trinomial. One term, that's one term plus a second term plus a third term. That's a trinomial. The way we multiply is by distributing or by doing area diagrams. I'm going to distribute this. So the 5x multiplies by the x squared to become 5x to the power of 3. It then distributes to the second term. 5 times 10 is 50. X times x is x squared. I then distribute it again all the way out here to the 2. 5 times 2 is 10x. And that is my answer. So again, it's like the exact same thing we did last lesson, just bigger. There's just more terms now. So it's just more numbers being written down, more to keep track of, more to organize. If we look over here, we have a binomial times a trinomial. For this one, I'm going to do area diagram so you can see what that looks like. So I take my first one, I'm going to write it down the side like this. And then I'm going to take my second term and I'm going to write it across the top. So 3x, 5y, and 10. And I make this nice little grid, which we will fill out. X squared times 3x is 3x to the power of 3. X squared times 5 is 5x squared y. X squared times 10 would be 10x squared. Across the bottom, 2x times 3x would be 6x squared. 2x times 5y would be 10xy. And then 2x times 10 would be 20x. Perfect. All the things in green is your solution. So I have 3x cubed plus 5x squared y plus 10x squared plus 6x squared plus 10xy plus 20x. But this time in our answer, we actually have one more step we have to do. Because if you look closely, you're going to notice you have like terms. You have two terms that have the same letter, same exponent. Those two things need to combine. So everything else is going to stay the same. So 3x cubed plus 5x squared y. But then those two terms are going to combine to be positive 16x squared, right? If I had 10x squared plus 6x squared, that's 16x squared. Everything else has either different letters or different exponents, so they cannot be combined. They cannot be added or subtracted. So that would be my final answer. Cool. Pause the video right now, go down here and try these two questions on your own and see how you do. When you unpause the video, you can watch me do it and see if you got the same thing as me. Okay, so for this first one, I'm going to do distribution. So I'm going to take this 2x, multiply it in to get 2x to the power of 4. Multiply it again to get plus 10x to the power of 3. 2 times 5 is 10, x and x squared is x cubed. Multiply it again here to get negative 8x squared. And multiply it again over here to get plus 10x. And that's my answer. If you did number 2, you could have done an area diagram or you could have done distribution. I'm going to distribute just so you can see what it looks like. So you take the 5, You distribute it to get 5x squared. Distribute it again to get plus 25y. Distribute it again to get plus 5x. Distribute it again to get negative 15. I'm then going to take the second term for my first polynomial, the positive y, and I'm going to distribute it to get plus x squared y plus 5y squared plus xy minus 3y. If you did an area diagram, your numbers and terms inside that area diagram should look the same as mine. When you're all said and done, you need to look for like terms. There is one there, 25y and negative 3y are like terms, but I don't think there's any other ones. So your final answer should have been 5x squared. Then we're going to say plus 22y. That's the yellow terms I just underlined. 25 minus 3 is 22. And then everything else, plus 5x minus 15 plus x squared y plus 5y squared plus xy. And those things all have either different exponents or a different combination of letters, so they cannot be combined. Awesome. Hopefully you paused it and got those all right. If you did that, then you're multiplying pro. Down here, we've got a couple word problems that we're going to do quick. So example 1 says determine the perimeter of a rectangle with a length of 7x minus 10 and a width of 4x plus 9. So if we imagine we have a rectangle, they've given me the width and the length. So a length of 7x minus 10 and a width of 4x plus 9. Now, because these are a rectangle, that means I know the other sides match, right? So I can fill this whole thing in. Like that. The first question says, determine the perimeter. Perimeter is all sides added. So if I wanted to add all my sides, I just have to write that out in one big sequence. So I'm going to do the top, which is 7x minus 10, plus the right side, which is 4x plus 9, plus the bottom, which is 7x minus 10, plus the left side, which is 4x plus 9. So all I've done is I've written out all the sides added together, because that's what perimeter is. And then I'm going to collect like terms. So if I have 7x plus 4x plus 7x plus 4x, that gives me 22x. If I look at the rest of the numbers, I have negative 10 plus 9, negative 10 plus 9. I put that in my calculator, I would get negative 2. So my perimeter would be 22x minus 2. Perfect. Part B, determine the area. Area is length times width. So if I want to do the area of this thing, I need to do 7x minus 10, that's the length, times 4x plus 9, that's the width. If you do distribution, 7x times 4, 742, 28x squared. 7x times 9 is plus 63x. Negative 10 times 4 is negative 40x. Negative 10 times 9 is positive 90. Oh, sorry, negative 90. And your final step after you multiply is to see if you have any like terms. We actually do here. So my final answer is 28x squared plus 23x minus 90. That's my answer. Cool. Last one. 3. This summer, Mr. Kennedy installed wallpaper in his 1972 motorhome. I actually did, and then my motorhome blew up, so we don't have it anymore. But I did wallpaper that thing before it exploded. If the wall he put paper on had a length of 6x minus 5 and a height of x plus 3, how much wallpaper did he need? How much wallpaper did Mr. Kennedy need That's asking me the area, right? That's saying how much area did you need to cover. And area is length times width. In this case, it would be length times the height of the wall. So I need to do 6x minus 5 times x plus 8. That would tell me the area, and that would tell me how much wallpaper I need. When you distribute, you get 6x squared. So 6x times x. 6x times 8 would be positive 48x. Negative 5 times x is negative 5x. And negative 5 times 8 is negative 40. My last step every time I multiply is collect like terms. So I get 6x squared plus 43x minus 40. That is how much wallpaper I would require to wallpaper my motorhome. Awesome. That's the whole lesson. So if you go to the next little page, there's 3 more questions there for you to try. They match up with these questions up here. So I'll write down the answer, but the work should be the exact same as the work above. Okay, so try your best to see if you can figure it out. I'll put the answers down so you can see if you got it right or wrong. Awesome. You should pause the video and then try these and then watch the answer. If we look at number 1, it's asking for perimeter again, so I should add all those sides. So x minus 1 plus x minus 1 plus 2x plus 2 plus 2x plus 2. If you did that, you should have got 6x and then plus 2. The area should have been your length times your width, which is x minus 1 times 2x plus 2. Whatever method you get, you should have ended up with 2x squared plus 2x minus 2x minus 2. And then you should have those two things right here, plus 2x and minus 2x, they equal 0 when you add them together, so they go away. So your area would have been 2x squared minus 2. And the last one, Mr. Kennedy wants to paint his classroom. To paint something is area. So you should have done x plus 5 times 2x plus 10. No matter what method you chose to do, you should have got 2x squared plus 10x plus 10x plus 50. You should have noticed that you had like terms, 10x plus 10x, and you should have got a final answer of 2x squared plus 20x plus 50. Wonderful. I hope you enjoy the rest of your day, and I hope to see you guys soon.